Hello friends, welcome to the fifth video in this series of videos on Introduction to Swift. In this video, we will learn about functions, closures, enumerations, and structures. Functions. A function is a set of statements organized together to perform a specific task. You give function a name that identifies what it does, and this name is used to call the function to perform its task when needed. Function declaration tells compiler about function name, parameters, and return types. Function definition is the actual body of the function. Every function in Swift has a type consisting of the function's parameter types and return type. A function's argument must always be provided in the same order as the function's parameter list. Return values in function are followed by an arrow sign. Functions in Swift allow us to pass local and global parameter values inside the function calls. In Swift, a function is defined by the func keyword, func. This is the prototype of a Swift function. Swift provides flexible function parameters and its return values. Thus, functions in Swift may take several forms. A function is accessed by passing its parameter values to the body of the function. We can pass single to multiple parameter values as tuples inside the function. We may also have functions without any parameters. Functions can also be used to return string, integer, and float data type values as return types. Some functions may have arguments declared inside the function without any return values. In Swift, we can have functions with optional return types as well. Optionals are used to check nil or garbage values, thereby consuming a lot of time in debugging and make the code efficient and readable for user. Functions without parameters and return types are known as void functions. For example, this is interest function defined by using func keyword. P, R, and T are the integer type parameters for this function, and it returns a value of type int. Now we have defined three variables P, R, and T outside this function. So to call this function to calculate interest on these values of P, R, and T, we can simply call the function and pass the parameters in the order in which they are defined. There are two types of parameters in a Swift function, local parameters and external parameters. Local parameter names are accessed inside the function only. External parameter names allow us to name a function parameter to make their purpose more clear. In this case of interest function, capital P, R, and T are the local parameters and small p, R, and T are the external parameters. When we want to define functions with multiple number of arguments, then we can declare members as variadic parameters. Parameters can be specified as variadic by three dots, as shown. Functions by default consider the parameters as constant, but you can declare the arguments as variable also. Input-output parameters in Swift provide functionality to retain the parameter values even after they are changed in function call. Inout keyword is used at the beginning of the parameter to tell the function to retain its value even after the function call. Only variables are passed as arguments for inout parameter because their values can be modified inside and outside of the function. Ampersand sign is used before a variable name to indicate that it refers to an inout parameter. For example, in this function, we have defined a swap functionality which takes two parameters and swaps their values. This function needs to retain the parameter values to indicate their swap. So, we have defined parameters a1 and a2 as inout. Then, at the time of calling swap function for the values of variables b1 and b2, we have used an ampersand sign before the variable. This ampersand sign indicates that we are passing values to in-out parameters and their values will be retained after the function call. When we try to print values for b1 and b2, we get the swapped values. This is an example of a variadic function where function has variable parameters of type int. Three dots are used to represent that there are variable number of parameters. While calling these functions, just pass the parameter name followed by comma separated values. A nested function provides the facility to call the outer function by invoking the inside function. Closures. Closures are self-contained blocks of functionality that can be passed around and used in your code. Closures in Swift are similar to blocks in C and Objective-C. Functions are actually special cases of closures. For example, global functions are closures that have a name and do not capture any values. Nested functions are closures that have a name and can capture values from their enclosing functions. Closures are unnamed and can capture values from their surrounding context. This represents the closure syntax. A closure is a block of statements and is enclosed inside curly braces, followed by set of parameters. This block of code can take, and then a return type. Return type is followed by word in, which indicates the start of the body of the closure. Closure expressions did not support default values. Variadic parameters and tuples can also be used as parameter types and return types. Closure expression syntax supports constant parameters, variable parameters, and in-out parameters. This is an example of closure which returns a value, and we have assigned that returned value to a variable divide. This closure takes two parameters, val1 and val2, both of the integer type, and returns an integer type value. Closure statements for calculation and return are written after in keyword. You can call the closure by the name to which this return value is assigned and pass the parameters in small brackets. Swift provides shorthand argument names to inline closures to refer to the values of the closure's argument by names $0, $1, and so on. Closure argument list is omitted in definition section when we represent shorthand argument names inside closure expressions. Since the shorthand argument is defined expression body, the in keyword is omitted. This is an example of a shorthand closure. First, we have declared a closure prototype and assigned it to a variable called shorthand. At the time of definition of this closure, we just mentioned the shorthand for second argument, that is $1, which means the value of this variable is the second argument mentioned at the time of calling this closure. Now, if we try to print shorthand hello hi, it prints hi because that is the second argument. Enumerations. An enumeration is a user-defined data type which consists of set of related values. Keyword enum is used to define enumerated data types. Enumerations in Swift also resemble the structures of C and Objective-C. Enum, if declared in a class, then its value can be accessed throughout the instance of that class. Initial member value for enumeration is defined using enum initializers, that is init function. Enumerations are defined using enum keyword and their entire definition is placed within a pair of braces. Values defined in an enumeration are its enumeration cases, and case keyword is used to define each such value. Unlike C and Objective-C, Swift enumeration cases are not assigned a default integer value when they are created. If you are familiar with C, you will know that C enumerations assign related names to a set of integer values. Enumerations in Swift are much more flexible and do not have to provide a value for each case of enumeration. If a value known as a raw value is provided for each enumeration case, the value can be a string, a character, or a value of any integer or floating point type. Sometimes it is useful to store associated values of other types along these case values. This enables you to store additional information. You can define enums in Swift to store associated values of any given type, and value types can be different for each case. This is an example of enumeration in Swift programming language. Here we have defined an enumeration called weekday with values Sunday, Monday, and so on assigned to each case. We can use enumeration in switch case as shown. We have defined variable for weekday whose value is Sunday. Now we can switch over the value of day variable and execute different set of statements for all the values in weekdays. Structures. Structures are flexible constructs that become the building blocks of your program. In structures, the variable values are copied and passed in subsequent codes by returning a copy of the old values so that the values cannot be altered. Structures are defined with struct keyword and their definition is enclosed inside a pair of braces. For example, here we have defined a struct named student marks containing marks of 3 subjects all assigned to a value. You can write functions inside structures to set or get values. Now we have created an instance of this struct and assign it to a constant called marks. To access the marks of each subject of this instance of student marks, use dot method. Checkmark is another example of a struct with an initializer. Init function initializes the value for this struct and you can make an instance of this struct by passing an argument mark to initializer as shown here. Swift provides the functionality to define structures as custom data types for the building of function blocks. The instance of structures are passed by value for further manipulation. Structures' primary purpose is to encapsulate a few relatively simple data values. Structures does not need to inherit properties or behaviors from other existing type. Use structures if you want to pass arguments by their values for an instance instead of reference. That's it in this video. In the next video, we will learn about classes, properties, methods, subscripts, and inheritance. Thanks for watching.